In this video we will demonstrate rock physics template on AVO data. So we are still working on the calibrate model project, and again you have a couple of options of where to initiate the AVO RPT. So we launch it here. What you need to do now is to make some specifications. First you need to consider if you're going to use a fixed layer above the model or the model above the fixed layer. And we will use the fixed layer above the model. This means that we are going to consider the transition between the caprock and the reservoir. To get some idea about the fixed layer properties, we open up and investigate the well log to see if we have some measurements above the reservoir. A nice feature to use is to uniformly set the axis limits. We extract this AVO RPT window to a separate window, and we can start to investigate. This is the reservoir zone. We zoom in a little bit, holding down the shift key and then dragging. And this is the top of the reservoir. So above here we enter the caprock. It's not always that you have measurements in this region. We do. Even if you do, it might be a little bit tricky sometimes to pinpoint the value that you use. You need to keep in mind that what we try to investigate here is a seismic wave passing through here, which has a lower resolution than the details that we see here. But we have to start somewhere, so we type in some values based on what we read from the logs. Next we need to specify the rock physics model we are going to use. So we choose the IRPM model that we have made. And then we need to specify the input data, the intercept and the gradient. And we can investigate a little bit what type of properties we can expect to see in the reservoir as far as the porosity, the volume fraction of shale, and the saturation. So what we will try to do is to use the AVO RPT to mimic those values when investigating the data in the area where the well log penetrates. So you can select regions in the seismic and they will show up in the crossplot. You can increase the point size here so they become a little bit more clear. And then we identify the second reservoir formation. We can rename these layers so that they are more easily identified. It is also possible to make a selection in the crossplot, and that will highlight the data points in the seismic. So you can use this tool to analyze the data. But more than that, you can also use this tool to scale the AVO data. The AVO data that comes in here are relative amplitudes, and they have automatically been scaled, but not necessarily correctly scaled. Using the template that we see here with the red and the blue lines, we can calibrate a better scaling factor. The red line is for a caprock unit above a hydrocarbon reservoir unit, and the blue line is for a caprock above a brine-saturated reservoir unit. The lighter blue and red lines are a caprock above a shale unit with brine and hydrocarbons. And these model trend lines are based on the specifications that we gave for the fixed layer and the rock physics model. The numbers that you see are the porosities for that reservoir unit. And we know that the porosity in the reservoir should be around 30%. But we see that the hydrocarbon reservoir trend line is not overlapping the data. So we need to start tweaking a little bit the scaling factors. Experimenting with this, you will learn a little bit the effect of changing the scale factors. But what we also notice here is that even though we change them, we are still not able to scale the data very well. It seems as if the data needs to be displaced, or the model lines need to be displaced compared to the data points. And this cannot be done just by changing the scaling factors. So this means that we have to do some tweaking in the specifications. And looking back at the well log, maybe we don't have the right specifications for the fixed layer. So if we tweak down, for example, the S velocity, we see now that the model trend line for the hydrocarbon saturated reservoir unit here is matching much better the first reservoir formation. The second reservoir formation is not plotting on top of the first reservoir formation. So there's something else going on there. And this might be that there is a little bit different property specifications for this intermediate shale layer between the two reservoir units. Or if you look at the data for the second reservoir formation unit, it's not as clean as the first reservoir formation unit. So in addition to using AVO RPT to analyze the data, you can use it to scale your relative amplitudes to absolute amplitudes, which is what we need if we are going to run IRPM on the AVO data.